Hello! Today I will be trying to help you gain intuition behind simple word problems that include using derivatives. So let's solve a simple problem right now, and let's take a second to read it. Okay, so this problem gives us a function which is f of t is equal to 3t squared plus 4. And what this function tells us is that given a time, we know the distance traveled by the car. So for example, at 4 seconds into the journey, the car would have traveled 52 feet. So again, given a time, we know the distance traveled by the car. However, the problem is asking us for the car's speed given a time, in this case 5 seconds. So if you were taught to solve this problem, you would have been told to take the derivative of this function, which would be f of t is equal to 6t, and you would replace the time with the time you're trying to find the car's speed at. So I'm trying to find the car's speed at 5 seconds, and that would give me 30 feet per second, which is around 20 miles per hour. So the car is traveling at 30 feet per second, or 20 miles per hour, at 5 seconds into the journey. So even though we know how to solve the problem, we don't really know why taking the derivative gives us the speed. So I'm going to try to explain that in our intuition example. So let's move on to our intuition example. And before we start, I want to remind you guys that the derivative at a point is really the slope at that point. So for our intuition example, we're going to do the same problem as before. And I'm going to write out the function again. The function that we are given, which is f of t is equal to 3t squared plus 4. And I'm going to write in English what this function tells us. This function pretty much means that given a time, we know the distance traveled at that time. So given the time, we know the distance traveled. That's what this function tells us. However, we're trying to find something where given a time, we know the speed at that time. So now I'm going to graph the original function very quickly. And it would look something like this, where the x-axis is time and the y-axis is distance. So let's go back to our sentence here. Given a time, we know the speed at that time. So let's try to translate this sentence into more mathematical terms. And you will see what I mean. So we have given a time. We know the speed. Remember, speed is really distance over time, right? So I'm going to replace speed with distance over time. Now let's translate it even further. Given a time, we know. If you look closely, distance is really the y-axis and time is really the x-axis. So we're going to replace distance over time with y over x. Let's go even further and write given a time, we know. Remember, y over x is really the slope. So we're going to end up with given a time, we know the slope. Now if you notice, the slope is really the same thing as the speed. If you remember in the beginning of this example, I reminded you guys that the derivative at a point is really the slope at that point. So when you find the derivative at a given time, you're really finding the slope at that time, which is really the speed at that time. And that's why when you take the derivative of a certain time, you find the speed at that time.